Okay, this lesson is about covariance of two random variables. In probability theory and statistics, covariance is a measure of how much two random variables change together. If the greater values of one variable mainly correspond with the greater values of the other variable, and the same holds for the lesser values, the variables tend to show similar behavior. The covariance is positive. So we're going to let x and y be random variables with joint probability distribution f of xy. And the covariance of x and y is denoted by sigma xy. And this is equal to, for discrete, this is equal to the expected value of x minus mu of x for variable x, and y minus mu of y for variable y. And this is equal to, as we've seen, the sums of the x's, because this is discrete, and the sums of the y's of x minus mu times y minus mu of y of times, and here would be a times f of x y. So this is that mu of x and mu of y. So we would sum up the x's, sum up the y's of x minus mu x times y minus mu y times f of xy. For continuous, it would be, instead of summation, we do integration. So the covariance would equal, would be the same. This would equal the integration of both x and y from minus infinity to infinity of x minus mu x times y minus mu y times f of xy dx dy. So this one's continuous and this one's discrete. A simpler formula is the covariance of x and y is equal to the expected value of xy minus mu x times mu y. Alright, let's talk about correlation coefficient. Although the covariance between two random variables does provide information regarding the nature of the relationship, the magnitude of the covariance does not indicate anything regarding the strength of the relationship. Since covariance is not scale-free, its magnitude will depend on the units used to measure both x and y. There is a scale-free version of the covariance, and that is called the correlation coefficient, and that is used widely in statistics. So we let x and y be random variables with covariance sigma xy and standard deviation sigma x and sigma y respectively. So the correlation coefficient of xy is written, it's actually rho, so you would write it as rho xy is equal to the covariance xy, it's the covariance of xy divided by the standard deviation of x times the standard deviation of y, and just remember those are the square roots of the variance. Let's look at means and variances of linear combinations of random variables. So if a and b are constants, then the expected value of AX plus B is equal to A times the expected value of X plus B. The expected value of the sum or difference of two or more functions of a random variable X is the sum or the difference of the expected values of the function. So let's take a look at what that would look like. So if you have the expected value of g of x plus or minus h of x, it would equal the expected value of g of x plus or minus the expected value of h of x. If c is a constant number, then the expected value of c is equal to c, and the variance of c is equal to 0. Because if it's constant, you know what it is. There's not really any variation. And for a and b constant, then the variance of ax plus b is equal to a square variance x. So if x and y are random variables, a, b, and c are constant, and they have a joint probability distribution as f of x, y, so then sigma square, or the variance of ax plus b, y plus c is equal to a square sigma square x plus b square sigma square y plus 2ab sigma xy. So that equals a square times the variance of x plus b square times the variance of y plus 2 times ab times the covariance of xy.